Uh, do you see my screen?
Yes, sir.
Okay. So, uh, can you tell me what is expression of Euler-Maclaurin's formula? So let me write it one more time for you. Can you tell me? Anybody? What are the expressions for Euler-Maclaurin's formula?
So integration x naught to xn y dx.
X naught to xn y dx equals to,
H by 2 y naught
okay,
plus
so
y.
the trapezoidal part. So x naught plus 2 times x1 plus x2 up to plus xn, sorry, xn minus 1 plus xn. So the trapezoidal part. Then
Minus h square by 12.
h square by 12 y dash xn, first derivative at xn minus first derivative at x naught, next term plus h for
H power 4 by 720.
720, okay, 720, h power 4 by 720,
Third derivative of y at xn.
xn minus third derivative of y at x naught plus minus h power 6 by 30240 y fifth derivative at xn minus y fifth derivative at x naught, and so on. You have to calculate the next term. So this is an infinite series. You will have to keep on adding successive approximation based on your requirement, how much accurate you want your answer to be. Okay, so this is the Euler-Maclaurin's formula. We discussed it, the derivation. So let us today solve some problem using this concept. Okay, so first I am giving you this series, finite series, and you tell me an approximate value of the series. So here the series is 1 by 51. Let me use the black pen. 1 by 51 square plus 1 by 53 square plus so on up to 1 by 55 square, so on up to 1 by 99 square. Suppose here 99 square. So what will be sum of this finite series? So which function, from which function you can generate each term of the series? First you have to identify the function. So what is y of x? What is y of x? From which function the terms are generated? One by x square. In that function you put x equals to 51, x equals to 53, x equals to 55 and so on. So each term will be generated. Now how many terms you are adding here? Can you tell me? How many terms you are adding? 51 to 99. Only odd values are there. Odd reciprocal of square of odd values. So how many terms are there? You have 25 terms. 25 odd numbers, but it is starting from x naught. So x naught is what? X naught will be starting from 51, and then you will have for 25 numbers to be added, then n has to be 24 because it is starting from x naught. So n equals to 24. So since it is starting from 0, so 0, 1, 2 up to 24, you will get 25 numbers. And what is the spacing between two consecutive x values? What are the spacing? What is h here? 2. Okay. So these are the results you know. Now you have to apply the formula. Nothing else. So see. So if y of x is equals to 1 by x square, then you know you will have to keep on adding the derivatives. So how many derivatives you want to add? First derivative, third derivative, fifth derivative. So depending on your wish, how much you want your answer to be accurate. So let us at least add two terms in the derivative, h square by 12 and h power 4 by 720. Those two terms at least let us add. So we need to calculate first derivative. So what is first derivative? What is y dash x? Minus 2 by x cube. And what will be third derivative then? Okay, let us calculate second derivative. So it will be minus plus, not minus, okay, minus plus 6 by x power 4. So third derivative will be minus 24 by x power 5. So these are the values. So I do not need the second derivative. So let us remove it. I do not need that. Okay. So let us suppose we are only adding these two terms, underline terms. You should be adding as many terms as possible because that is an infinite series. So let us add only first two terms, the first two improvements. So use then the Euler-Mclaren's formula. So if you call the formula this is A, then what you will get from A? From A, sorry, what you will get? Integration left hand side, x naught is what? 51, xn is what? 99, dx by y x square. So 1 by x square. So 1 by x square dx. Right hand side is 2 by 2 since h is 2. X naught is 51 plus 2 times. Oh, not x naught. These are y naught values. Y naught plus 2 times. So it will be y naught will be 1 by 51 square. 1 by 51 square plus 2 times y1 plus y2 up to yn minus 1. So it will be 1 by 53 square plus 1 by 55 square up to 1 by 97 square plus 1 by 99 square. Okay. Minus h square by 12. So h square by 12 will be 4 by 3. You have to evaluate first derivative at xn. So what is that? You have to evaluate first derivative at x equals to 99 minus first derivative at x equals to 51. So that will be minus 2 by 99 power cube minus 2 by 51 power cube. And if you consider the next term, that will be h power 4 by 720. So h power 4 by 720 will be minus 16 by 720 What will be the next value here? Minus 24 by 99 power 5 minus minus 24 by 51 power 5. That's not it. And you may stop here because in the next term denominator is what? 30240. So that value will be very small quantity. So if you wish, you can only consider two terms. If you wish, you can add also the third term or the fourth term depending on your wish. Okay. So that will be increasing. If you keep on adding more and more terms, that will be increasing the accuracy of the number. So from here you will get what is on the left hand side. What is on the left hand side?
Sir, in the
So
second term, it is 4 by 12 now.
4 by oh, it is 4 by 12. Why did I write 4 by 3? Maybe by mistake. It is 4 by 12. This one is 4 by 12. Yes, let me see the formula. Yes, 4 by 12. So left hand side you integrate it. So this is minus 1 by x, and then you have to put upper limit and lower limit. So you will be getting left hand side will be minus 1 by 99 minus minus plus 1 by 51. Okay, left hand side. And what is on the right hand side? Now if you want to make the given series, what you do, since the intermediate terms are added twice, so let us make the whole thing symmetric. So we add one more 1 by 51 square and 1 by 99 square, and then you subtract that value. Okay, so that it will be 2 times the whole series. So that will be this two is cancelled out. So this will be suppose the given series is equals to k. Okay, so it will be k minus 2 times k minus 1 by 51 square minus 1 by 99 square. And then you simplify how much you are getting. Use calculator and tell me what are the values. What is this circle values? 4 by 12, huh? That term, and minus 16 by 720 that term. So tell me the approximate values for those. So it is coming minus 2. I can take common, minus minus plus. So it will be 2 by 3 plus 2 by 3, 1 by 99 square minus 1 by 51 square minus minus plus. It will be here it was plus symbol, sorry, it was plus symbol, so it will be again minus. So it's plus symbol, so it will be minus 24 into 16 by 720. So if you simplify, that will be 8 by 15, 1 by 99 power 5 minus 1 by 51 power 5. Then you simplify whole thing, that is a simple algebraic calculation, and you'll end up with k equals to 0.0059. Right? This is the approximate value. Some truncated values will be there, so truncation error will be there, and since you are not considering the fifth order derivative, seventh order derivative in the formula A, so this is an approximate value of the finite series. So this is how you can use Euler-Maclaurin's formula to find out the sum of a series. Now let us use this formula to find out the value of an integral, definite integral. So let us use this formula, okay, with some very small or easy integration so that we can compare its approximate value and its exact value. So here this is the problem. Later you can use it to any kind of definite integration. So the problem is use Euler-Maclaurin's formula to find log e base 2 from the integral integration 0 to 1 dx by 1 plus x. So this integration is very easy. If you this is a log of 1 plus x, so then it will be log 2. Log of 1 plus x, then you put the upper limit, lower limit. So this is log 2. So whatever the value of this integration is, that will be log 2. So use your calculator and find out the value of log 2. And then let us try to find out the value of log 2 using Euler-Maclaurin's formula. So you have to solve that definite integral using Euler-Maclaurin's formula. So what you have to do? You have to, if you want to solve definite integral by numerical techniques, what you have to do? You have to create data points. So first you decide which formula you want to apply. So here it is already mentioned Euler-Maclaurin's formula. So Euler-Maclaurin's formula, trapezoidal part is there. So you do not have to worry about the number of data points. You decide how many data points you want to create from 0 to 1. So tell me how many data points you want to create from 0 to 1. Tell me. So here y of x is the function 1 by 1 plus x. Y dash x is minus 1 by 1 plus x whole square. And if you find out double derivative, so double derivative will be 2 by 1 plus x whole cube. So it will be y triple derivative will be minus 6 by 1 plus x power 4 minus 6 by 1 plus x power 4. So we are planning to add only two terms, two approximation in the formula A. We do not want to add the third term. So we'll be stopping only after adding two terms after the trapezoidal part. So here, tell me how many data points you want to create. Okay, so let us
Sir,
create
3.
थ्री बहुत कम हो जाएगा, 3 पे मत करो, 3 करेंगे तो बस बीच पे 0.5 भी हम लोग कंसीडर कर रहे हैं. सो फंक्शंस बिहेवियर विल नॉट बी properly cast by that data points. So at least let us create 6 data points from 0 to 1 in 0.2 interval. Okay, so what will be the value of the integration then? Tell me what will be the value of the integration then? Integration 0 to 1, if you create 6 data points, what will be h? For 6 data point, 0, 0.2, 0.4, 0.6, 0.8, 1. So 6 data points, h is 0.2. So integration 0 to 1 dx upon 1 plus x is h by 2. So it will be 0.2 by 2. Okay. First output value at x equals to 0. So it will be 1 by 1 plus 0 plus 2 times the values at the intermediate input data. So that will be 1 by 1 plus 0.2 plus 1 by 1 plus 0.4 plus 1 by 1 plus 0.6 plus 1 by 1 plus 0.8 plus 1 by 1 plus 1. This is the trapezoidal part, yes or no?
Yes, sir.
Now next you have to consider the derivative part, the successive approximations, successive improvements. So they are what? Minus h square by 12. So minus h square by 12. So h is 0.2 square by 12. Okay. First derivative at 1. So first derivative at 1 will be minus 1 by 1 plus 1 whole square minus first derivative at x equals to 0. So minus minus plus 1 by 1 plus 0 whole square. Okay. So next term is how much? Minus minus plus. Next term is plus term. H power 4 by 720. H power 4 by 720. So plus h power 4 will be 0.2 whole square by 720. It will be minus 6 by 1 plus 1 power 4 minus minus plus 6 by 1 plus 0 power 4. So I am stopping here. So now you have to simplify this. So you take your time and tell me how much value what is the answer of this. So you have to simplify the terms. And let me use the calculator to find out log 2 e-base. Then I'll be, so why don't you calculate this expression? Simplify this expression and tell me the value of the integration 0 to 1 dx by 1 plus x. Calculator. Just a moment. Please simplify the expression and tell me the answer of the integration. Here it will be ln ln 2. So this point. So according to the calculator, the value is 0.69314718. 4718. Remember, if you consider a large number, then behavior of the function is not properly attained. Okay. So your aim should be consider h as small as possible. So if you consider h to be small, then to cover the whole interval, the whole range of the definite integral, you will have to create more data points. So that's a disadvantage. But if you want your answer to be accurate, you have to do that. So what is the value of the integration? Did you solve it? Anybody? If not, then I have to solve it, or otherwise I'll leave it with this. You complete it. Let us give. Let me give you 5 more minutes and let me see if anybody is solving it. And I also will be trying to solve it in the meantime. So this is point 2 by 2. Okay, I'll leave you. I will leave it with this part. You do the calculation. You will see it will be correct up to
Sir, it is coming 0.69782.
69.
782.
Are you sure? 69.
0.69.
Sir,
0.69782.
it is coming. Sir,
Yes.
my answer is coming 0.69288875.
0.69. 0.69. Just a moment.
288.
75. 28875. Okay. So
Yes, sir.
it is close. They are corrected to 2 decimal places. But if you consider 10 data points, instead of considering 6, then according to from the book, I can see the calculation will be correct up to 5 decimal places. 6931. If you consider 10 data points, for 10 data points, your answer will be correct up to 5 decimal places. Your answer will be, answer is equals to 0.693149. So you see that is correct up to 5 decimal places. So this is how you can use Euler-Maclaren's formula to solve definite integral. Now remember here, the integration was or integrand was known to you. When the data points are given to you instead of the function integrand, then what you have to do? The trapezoidal part you can calculate as usual, and derivative part you can also approximate. You know how to find out approximate value of the derivative because first part of the unit was that. So from there you find out the approximate value of the derivatives and use them in the formula. So that you can do when the integrand is not given, instead data points are there. Okay. Okay, fine. So I'll be completing the unit at this point. Based on the requirement, I may revisit this particular unit and I may discuss few more concepts later at the end. So next unit will be about system of linear equations. system of linear equations. Though it seems, why should we study system of linear equation? We know how to solve it. We know by elimination method, by substitution method, is not it? But those techniques which you are saying, elimination method or substitution method, they will be working fine if the dimension of the system is less. For 3 cross 3 system or 4 cross 4, you may solve that system of linear equation by elimination method or by substitution method. But when the system, dimension of the system is large, you will not be able to do it by hand, and even if you do it by hand, there is a huge possibility that you will be making some mistakes. Suppose the dimension of the problem is a 10 cross 10 or 20 cross 20 or worst case 100 cross 100 or maybe more than that, then it will be very difficult to solve by hand. So you need a sophisticated technique which you can write down in terms of code, and computer will do the job for you. So there should be a systematic way. So that is what we are going to discuss. First, we will be discussing few direct techniques where you will get exact answer, because the calculation will be stopped after a finite number of operations, and then we will be learning some iterative technique where you will start with some initial solution, initial guess, and each step you will keep on improving that solution until you get the solution with desired accuracy. So that is what we are going to learn. Solving system of linear equation. Solving system of linear equations. Now, before I start discussing the system of linear equation, let me ask you, do you know any method to solve system of nonlinear equation? I have already discussed. Anybody? If I give you two system of nonlinear equation, let's say two equation, two unknowns, or let's say three equation, three unknowns. I discussed one iterative method to find out a solution of system of nonlinear equation. Can you tell me what was that? You can use Newton-Raphson method for function of several variables. I use that technique in Lean-Bearstow method. You will start with some initial guesses, and each iteration you will be keep on improving the solution. So you can use that Newton-Raphson method for function of several variables to find out the solution of a system of nonlinear equation. You can also use that to find out the solution of linear equation, but that will not be uh, very much accurate every time. Not accurate. We can have a better method. Okay, so that is what we are going to ask. We are going to discuss. So suppose, so you have studied little bit about system of linear equation in second semester, yes or no? When we discussed vector space concept, we discussed Gauss elimination method. Huh? Maybe you do you recall in vector space you studied system of linear equation. Suppose this is the system of linear equation. Huh? A11 x1 plus A12 x2 up to A1n xn equals to B1. Then another equation A22 x2 plus A2, oh sorry, A21 x2 plus A22 x1 x2, so on up to A2n xn equals to B2, and this will continue up to nth equation. So n1 x1 plus an2 x2 up to an xn equals to bn. So how many equations, how many unknowns are there? N equation, with n unknowns. So if you write down this system of equation in matrix form, it will be of the form A, it will be matrix of order n cross n, X, it will be a column vector equals to B, B is another column vector. So this is the system of equation in matrix form. Now you have studied when this system is consistent, A is called the coefficient matrix, coefficient matrix. Okay, B is called the unknown column vector, right hand side column vector. X is the unknown vector. So here, what is A bar? What do you know about the consistency of this system of equation? You had studied some results that the system is consistent if rank of A equals to rank of A bar. A bar is what? A bar is the augmented matrix. If you consider the matrix A and also you add the right hand side column vector, so if you consider that as a column and also you consider the whole matrix A together, this is called the augmented matrix. Now you know if rank of A, if rank of A equals to rank of A bar equals to n, the number of unknowns, then it has the system has unique solution. You have studied it. Then if rank of A is equals to rank of A bar, that is less than n, then the system has infinitely many solutions. Infinitely many solutions. And if rank of A is not equals to rank of A bar, rank of A, rank of A is not equals to rank of A bar, then the system has no solution. System of equation has no solutions. So what we are considering here in this unit, we are considering that rank of A equals to rank of A bar equals to n. That means the system has unique solution. So the given system of linear equation has unique solution. That is the assumption in this unit, and our aim is to find out that unique solution. So in this unit, what we are going to learn, we are going to learn some techniques to solve system of linear equation. Let me tell their name. So that will be, first will be LU decomposition method. LU decomposition method means we'll be decomposing the coefficient matrix A into product of lower triangular matrix and upper triangular matrix. Okay. Why? I will be telling you that. Why will be doing that? Because while doing so, we can comparatively easily solve the system of linear equation. It will be easy compared to the elimination method. Second one we are going to study will be L transpose or Cholesky decomposition method. Now, this method you cannot apply every time. This Cholesky decomposition method, you have to the matrix will have to satisfy certain condition, the coefficient matrix, then only you can apply this Cholesky or LL transpose decomposition method. Third technique we are going to learn will be the iterative techniques. So these two will be direct methods. Direct methods means you will be able to obtain the solution after a finite number of steps or operations. So this way your answer will be exact. And these two methods, third and fourth, they will be iterative methods. So first one will be Gauss-Seidel method, Gauss-Jacobi, Gauss-Jacobi method, and another will be Gauss-Seidel method. So they will be, these will be iterative methods. Iterative means what? You will start with some initial guesses. You will start with some initial guess, and after each iteration, after you will get improved solution, and you will keep on repeating the process until you get the solution with desired accuracy. Now, why we are bothering about these techniques, for example LU decomposition or LL transpose decomposition? Because in certain kind of system of equations it is very easy to obtain the solution. For example, if the system of equation is like this: a11 x1 equals to b1, a22 x2 equals to b2, a33, so let me write down in a proper format. So suppose a11 x1 equals to b1, a22 x2 equals to b2, and a33 x3 equals to b3. If this is the system of equation, you can very easily solve x1 x2 x3, is not it? If this is the system of equation, a11 x1 plus a12 x2 plus a13 x3 equals to b1, a22 x2 plus a23 x3 equals to b2, a33 x3 equals to b3. Can you solve the system, the second system, very easily? Can you solve it? The second system, that is upper triangular system, because you see the lower part, if you consider this is a coefficient matrix, then you will see in the coefficient matrix below diagonal elements will be 0. So this is upper triangular system. Can you solve it? Can you solve it easily? What you have to do? You have to use back substitution. From last equation you calculate x3, then use that solution in second equation to calculate x2, then use previous two solutions x2 and x3 in first equation to get x1. So by using backward substitution, you can obtain the solution very easily. Using backward substitution technique, using backward substitution technique, solution can be obtained very easily. And remember, we are assuming that the system has unique solution. So we know the solution exists and it is unique. So we'll be ending up with a lower triangular system. So this is upper triangular system. So if you consider a lower triangular system, so suppose you are given this kind of equation: a 13 x3 equals to b1, then a 22 x2 plus a23 x3 equals to b2, then you have a 31 x1 plus a 32 x2 plus a 33 x3 equals to b3. How can you solve this equation? Using forward substitution. Okay, so using forward substitution you can easily solve this system of equation. So if the system is one of these three, then you can easily obtain the solution. So what will be our aim in Gauss in LU decomposition and LL transposition, uh, in LU decomposition method or LL transpose or Cholesky decomposition method? Our aim will be to convert the given system to one of these kind, so that we can easily obtain the solution. Okay. So in next class we are going to, I'm going to provide you some examples that system of linear equations will be appearing in your subject very frequently. I'll give you some examples for that, and then we'll be start discussing each of those methods in details. LU decomposition method, then LL transpose decomposition method, then Gauss-Jacobi, and then Gauss-Seidel. And at the end of this unit, we'll be discussing one more topic, that will be eigenvalues of a matrix. You have studied that eigenvalues in semester 2 in vector space concept. You studied what is eigenvalues, eigenvectors. So here also we are going to consider some numerical techniques how to find out eigenvalues of a given matrix, and we'll see some application of those concepts. What is the need of eigenvalues, finding eigenvalues of a matrix? Okay, so those things will be discussed. So I'll be stopping here. Anybody having any doubts, you can ask me. Any doubts, anybody?
No, sir.
Okay, fine then. Remember, you should be attending the classes. This unit going to be very easy. Solving system of linear equation. Okay, fine then. If you do not have any doubts, you may leave the class. So let me stop the recordings. So here, stop.